Wars continue. If you open up the Robinhood app and you check any cryptocurrency, you'll notice this cool 80s style animated neon horizon. Today, we're going to clone that with Flutter. But before we get into that, are you subscribed to this channel yet? If not, why not? It's real easy. Just go down and click that red subscribe button, maybe even click that notification bell so you can keep up with the Clone Wars. And also, if you really enjoy this content and you want to see lots of more clones in the future, I've added the ability to join the channel and provide a small amount of financial support. Any support that some of you may offer is greatly appreciated. Now let's go clone this neon horizon. You can see a video from the actual Robinhood app here, and we want to recreate just this animated neon horizon right up here in our Flutter app. You can see here in the code under scaffold, we have this text that says, let's clone something. So let's go ahead and clone something. I've created an empty widget already, which is called Neon Horizon. We'll come over to that file and you can see here that it really is an empty widget. So now let's start the cloning process. The first thing we want to do is take a step back and we want to ask, how should we solve this problem in Flutter? And there are some questions we want to ask ourselves to help us answer the root problem of how to solve this. First, are we doing any custom child layout, any kind of layout that we wouldn't be able to accomplish with a widget tree? The answer to that is no. In fact, we don't have any children at all. Okay. Are we doing any custom hit testing? Any hit testing that's based on our layout where, let's say, a gesture detector wouldn't do the job for us? No. In fact, we don't need to worry about gestures at all for this animated horizon. Well, the final question is, do we need to do any custom painting? In other words, do we need access to a canvas? And there we absolutely do. We're not animating widgets on our screen. We have one widget and we want to paint some lines and some gradients. And that tells us, the answer to those three questions combined tells us what we want is a custom paint widget with a custom painter. So let's begin there. We'll get rid of this container and we will return a custom paint widget. It wants a painter. We'll create that in a moment. Neon Horizon Painter. And we're also going to make this custom paint as large as it wants to be. In this case, that'll just be the size of our card. All right, now we'll come down here and we'll define Neon Horizon Painter, extends custom painter, and we will generate these two methods. For now, we'll return false in should repaint. We'll worry about that later perhaps. And then the interesting stuff happens here in paint. So let's save this. And see, it's doing a little reload here. Okay, now it's blank. That's what we expect because we replaced the text with our new widget, and all our new widget does is create a custom paint that paints nothing. Let's start by painting the background. And it might be a little difficult to see here in this video, but there appears to be a slight gradient in the background. We'd like to paint that gradient here in this paint method. We'll just say paint background. We'll pass the canvas and we'll pass the size. So now our goal is to implement paint background, canvas size. What do we want to do here? Well, we want to paint a gradient. How do we do that? The paint object has a property called shader, and there's a very small number of shaders that we can pass to that or set on that paint property. One of them is a linear gradient. That's what we want to do, is we want to create a linear gradient with appropriate color. But before we create the gradient, let's just go ahead and paint a solid color to make sure that we have the right rectangle, the rectangle that we think we have. we'll say canvas, draw rect, and we want to fill the available space. To accomplish that, we'll take offset 0 and we'll combine it with the given size. This generates a rectangle at 0, 0, that is the size of size, and then we will pass in the background paint. Let's save that. There we go. Now it's white, so it's kind of white on almost white. You probably can't see it, but that does mean that we are painting what we think we're painting. But this also begs the question, what color should we be using here? The background should be based on the color of the lines. So let's take that in as a property here, because sometimes it's green, like when the price of crypto goes up, and sometimes it's red, like when the price of crypto goes down. So we'll take in a primary color. And that is required. Now that we're taking in a property, we have something to stick in our should repaint method. By the way, we're going to come down here and we're going to replace this custom covariant custom painter with, what do we call this, neon horizon painter. And then we're going to say if our primary color is not equal to the other painter's primary color, then something has changed and we need to repaint. And we'll probably add some more properties to that method as we continue. Now we need to pass the appropriate color in here. For the moment, let's just quickly put in green. And then in our paint background, let's use our primary color. Now we're painting the primary color and it's green. Okay. So now how do we get that gradient that we were talking about before? Well, instead of setting a primary color, let's set this shader property. And we'll set that equal to UI gradient linear. Now the reason that we have this UI in front is because this particular gradient comes from the Dart UI package. So this is not from your standard widget material Cupertino package. This is from Dart UI. And typically when you import Dart UI, you give it this UI prefix because a number of things in the Dart UI package have the same name as things from material or widgets. Within that Dart UI package, we're using its definition of a linear gradient. Again, this is a different definition than the linear gradient that you would pass to, let's say, a container. They're used by two different parts of Flutter, so they have different definitions. In any event, we need to say where the gradient starts, where it ends, and what colors it traverses. Now again, if you've used linear gradients in other areas of the widget tree, you might be used to passing in alignments here. But see, we're actually painting pixels. So we're not dealing with alignments or percentages, we're dealing with actual pixel values. So we're going to say offset.0 is where we're going to begin, and then where we're going to end. The X here doesn't really matter because we're going vertical, but we want to end at the height. We're actually saying in pixel values where we begin and where we end. And then the question is, what colors do we want? Well, let's take our primary color and let's have let's start up top with an opacity of, I don't know, 45%, and then go down to 15%. Actually, I think I have those reversed. Let's say 40, let's say 15 up top and let's say 40 on the bottom. Let's save that. All right, now check over here. It might be difficult for you to see in the video, but we have a slight, the whole thing is green. It's slightly brighter down here on the bottom. Gives us a little bit of kind of, it looks like kind of bleed off from lights down here at the bottom, and then it gets darker, darker as if you're fading off into the horizon, which is exactly what we're trying to build. Okay, that is our background. Now it's time to paint some vertical lines. So we want to paint vertical lines, and then we want to paint horizontal lines. And I guess this would also be a good time for me to discuss another aspect of our approach. What we're looking at is a perspective effect. And in theory, what we could do is just draw a flat rectangle with lines and then apply a perspective transform that causes that flat rectangle to look like it's going off into the distance. That's actually a fine solution. There are two things to keep in mind. First, the math on that is going to be far more complicated. You're going to have to understand how to apply and what a perspective matrix means. It's not inaccessible. You can figure it out, but it's more than we need. But the second detail is more important because, again, we're thinking as app developers or UI developers that are working on products. Our designer probably came to us and said, we want this horizon to be 300 pixels tall on the screen. Well, the thing about applying a perspective matrix is that you have complete control over the flat rectangle, but the height of the overall horizon after you apply the perspective is based on the angle of the camera, the angle that the camera is looking down at the horizon. So you kind of lose control over the final height of the horizon because it's determined by the camera. Instead, we'd like to gain exact control over the final sizing of all of this. And so what we're going to do is imitate perspective. We're going to draw lines that kind of look like perspective, but we're not going to worry about actually having a legitimate projection matrix, a perspective matrix that converts flat lines into perspective lines. It's not worth it to us in this case, okay? So what we're going to do instead is we're going to figure out how to paint the vertical lines that look roughly like a perspective, and then we're going to paint the horizontal lines that animate up, and those need to be spaced in a way that it looks like perspective. Let's solve the vertical lines first because they don't move. Our strategy here can be to draw the center line, which is vertical. It's straight up and down. And then we can go left and right and essentially mirror the same lines on both sides until we get to the edge of the screen. Let's start by drawing that center line. First, we need a paint. We'll call it line paint. And its color is going to be the primary color. And its width is going to be 2. We're going to have lines with a width of 2. That, of course, can be anything you want. And we want this first line down the center. We're going to say canvas, draw, line. The first offset is going to be what will be the center X. We'll calculate that in a moment. And 0 on the Y, which is the top. And we're going to go to center X size.height, which is the bottom, and we're going to use the line paint. Now let's calculate the center X. Size.width divided by 2. Save that. And there we go. There's our very first line. Now our goal is to essentially loop 1/2, to loop from the center to, you could say, the right side, and draw all the angled lines along the way, and also mirror those same angled lines to the left so that we end up with angles on both sides in opposite directions. We're going to use a couple of variables here to help us out. First we're going to have a property which is called spacing. And this number can be anything you want. But what I'm going to do is I'm going to space every line by 45 pixels. Again, you can make it larger, wider apart, more narrow, whatever you want. And then we're going to track, so we can do that down here, we're going to track a delta x. Delta x meaning the space from the center. I guess this can be a const. Delta x is the amount that we move from the center. So let's say that while center x minus delta x is greater than 0, meaning, So we're instead of moving to the right, we're going to move to the left because 0 is a more convenient number to check than the width of our available space. So we're kind of counting down towards the left. Now every movement through this loop, we're going to say delta x plus equals spacing. And spacing is complaining here because it thinks it's an int. We'll make it a double. All right, this loop right here already has a termination condition now because we are, oops, this should be subtraction. Eventually we're going to get to 0 and then this loop is going to exit. Now let's draw another line. Let's say canvas, draw line, offset. This time we're going to say center x minus delta x. And we're still going to start at the top. And then we'll say offset center x minus delta x at the bottom, which is size.height. And then we're going to use the line paint. Save that. Oh, no, I think I gave it an infinite loop. Minus delta x, this should have been a plus. And we're going to accomplish that by simply multiplying our delta x by 2.5. Again, we're not worried about the correct perspective here. We're just worried about something that looks close enough. Save that. And there you go. Already you have that feeling of perspective. It feels like we've got a perspective plane now. Which means the only remaining problem is to draw these animating lines moving up. That's actually two problems in one. First, we need to somehow animate them. Second, they need to be spaced correctly. That's the tough part, spacing them. We'll start by spacing them evenly, and you'll see how bad that looks, and then we'll have to figure out what we're going to do about that. Now, to start the process of drawing these animated lines, the first thing I want to do is actually come up here to our widget, and I want to add a property. Actually, we'll add two while we're here. We'll add one for the color, and then let's also add a boolean for is animating. And that's because I want to be able to easily toggle the animation on and off in case we run into problems along the way. So we'll say required this.color, and then we'll say this dot is animating. By default, that is going to be true. Now we need to come back over here to neon horizon, and we need to pass in a color. All right. Next, we need to pass that color through. We need to pass it to our painter. We'll say widget.color, and we'll save, and everything should still be good. Nope. Okay, well, a hot restart seemed to fix that. Now, how do we deal with animation? Unless you're using kind of implicit animations or kind of widget animations, the answer to this question is always the same, which is our state object should implement a ticker provider mixin, and we should create a ticker, and that ticker will be the animation. So we will say with, in this case, single ticker provider, we only need one. And then we're going to have a late defined ticker. Now in this case, we know that we might always want a ticker, so there's no need to kind of have it nullable. We'll just always keep it around. In init state, we'll call through to the super method, and then we'll say ticker equals create ticker. This is a method that we inherit from our mixin, and we'll need to pass a callback for onTick. We'll deal with that in a moment. Now, if widget.isAnimating, we need to start the ticker. Then we need to, of course, dispose of our ticker. We'll say ticker. First, we will stop it just in case it's running, and then we will dispose it. All right, now let's stub out this onTick. We need this onTick is what's called by the ticker, and it receives the elapsed time since it began ticking. This isn't, unlike some other timers and things, this isn't the time between ticks. This is the total time that has passed since we started the ticker. And we'll do something with that later. Now there's one more detail we need to cover here. When you have a widget property that can alter what you're supposed to do in your state object, you need to override did update widget and make those changes accordingly. Here what we need to say is if widget.isAnimating is not equal to old widget.isAnimating, this means that either we were animating and now we shouldn't, or we weren't animating and now we should. So if, based on that condition, if widget is animating, we need to start the ticker. Otherwise, it means the reverse situation happened, so we need to stop it. And that's critical for our ability to actually use hot reload, for example, and change that widget value from animating to not animating, animating to not animating. Now, what is our philosophy for how we're going to apply these ticks to the painter? What I'm thinking is that first we want to be able to draw a single horizontal line that animates all the way up to the top and then starts over again. If we can get that working, then we can kind of extend and massage that into what we want. Let's create a variable in our state object. We will call it, let's say, distance %. Not a great name, but hopefully you get it. It's the % from the bottom to the top. It's the % of the distance into the horizon. And then in onTick, we will set state and we will say distance %. Now we could set this based on the elapsed time exactly. Like we could say it equals elapsed time dot in milliseconds divided by 100 or something. But then as we start and stop our timer, we're going to get our ticker, we're going to get jittery effects because the elapsed time will go back to 0. I'm thinking that maybe what we want to do is just say distance % will add to it. And that way, even when the elapsed time goes back to 0, our line doesn't jump anywhere unexpected. Now so in milliseconds, so every second we have 1,000 milliseconds. So think about like how many pixels might we want to move in a second? And we can obviously play around with this number. I think 100, now maybe divided by 10 is better. So we'll move 100 pixels per second. That's still probably too little, but whatever, we'll see what happens. And then when distance % gets to 100, that's another thing, is these aren't actually pixels, this is a percentage. So let me reevaluate this. Let's instead think about how much time it should take to go from the bottom to the top. You know, let's say that's const duration let's say 3 seconds. It takes 3 seconds to go from the bottom to the top. And we can access that in milliseconds, okay? Let's cut that out. Now let's say elapsed time divided by that number. So let's say, you know, if 3 seconds went by, which it won't, like a fraction of a second will go by. But if 3 seconds goes by, then this comes out to 1 or 100%. So we jump from the bottom to the top. That's what we would expect. But now let's add one more adjustment here. We don't want to go beyond 100%. So we'll say distance % equals distance % mod 1.0. This essentially just gives us the remaining fraction. So we loop back to the beginning. Okay? Now if we save this, nothing's going to happen because we aren't using this value anywhere. We want distance % to go to our painter. So in our painter, we will say final double distance %. We will require that as an input. We will pass that through. And now down here in our painter, we want to start painting horizontal lines. Let's start with canvas, draw a line. We want to go from the left to the right, so x0 to size.width, and then the height is based on the %. So we start at 0, and we'll do the height in a moment. And then we go to size.width, and we'll do the height in a moment. And we want to use the line paint. Now, what should the height be? Well, remember that in our case, 0, we want to start at the bottom, and 100%, we want to go to the top, which means we actually have to subtract the percent from the height. So size.height minus size.height times the distance percent. We're subtracting from the bottom. Now we can also simplify this. We can extract out the height, and we can say 1 minus the distance percent. And that gives us the same number. Assuming I did that correctly. We'll see. I might have to do a hot restart here because we added the ticker capability to our state object, but let's see. Okay, I had to do a hot restart to get the line in there. Now we've got the first line. That's good. The question is, why isn't it repainting? And that's probably because down here in should repaint, our color isn't changing, and that's the only thing that triggers a repaint. So what we want is, we also want to check if the distance percent has changed. And there's our line, but clearly it's going crazy, so we've got something messed up in our calculation. And I can see here, well, the total elapsed time divided by 3 seconds, in theory, I think that should work. But let's look a little deeper here. First, let's see what, instead of adding, let's just assign it and see what happens there. Okay, assigning it worked. So there's something in my math about treating this as a delta that clearly isn't working out. For now, we'll just go with this. Again, it's only a problem if we start and stop the animation. As long as we continue animating the same animation, we'll get continuous motion. So now you can see that we have that kind of animating into the distance effect, which is good. What about all the other lines? Well, let's go try to paint the other lines and see what happens. If we're going to draw a bunch of different lines, we need to know how much, not necessarily space is between them, but what the difference in the distance percent is. So remember, 0% is at the bottom, 100% or 1.0 is at the top. So we want something like a distance delta. And let's set that to, let's say, 10%. So each of our lines are in theory, are 10% separated. And then let's have a y value, which is equal to, we'll start with that as the given distance percent. And we'll say while y is greater than or equal to 0, and we will add, we will subtract the distance delta. This is similar to what we did before with our vertical lines, but now we're doing it horizontally. So we're moving the y up, 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 up. And then we will grab this line. And what we want to change, we want to say, instead of distance percent, we will say y. And actually, so we're mixing two different concepts here. So let's say we already have distance percent. We're never going to use distance percent again in this method, so I think we can change it here. So for the y value should actually be the y value, not a percent. So let's take this calculation right here. And there's our y value. So as long as y is greater than 0, we will take down here, we will say distance percent minus, actually, so for percentages, we will say plus equals distance delta. So we're, in theory, we're starting, this is the reference line, but let's say we're starting at 0. Oh, it says it can't be assigned because it's final. Okay. We will say current line distance percent, and that's going to equal, it's going to initialize to the distance percent that we're given in our painter. And then we will take this variable and we will update it. So we're going from like 0 to 0.1 to 0.2 to 0.3. That's what's happening on this line right here. But then our y value, we need to update, we need to set it equal to our pixel calculation. There's our new y value. That's a pixel value. And then we keep looping until we get down to 0 or less. Okay. And then we're now calculating the y value, so we can just pass the y in for the offset. And I guess this wants to be const, that's fine. Let's save. Okay, and now we have a bunch of lines here. Two problems. First problem is that obviously only lines above our reference line appear, and that's to be expected because we start with right here the distance percent for the reference line, and then we just add to it going up, up, up. The second problem is that all of these lines are equally spaced vertically, which ruins our sense of perspective. They should not be spaced evenly. The lines near the bottom should be further apart, and the lines near the top should be closer together. So first, let's solve the problem of drawing the lines below our reference line. And here's how we're actually going to deal with that. We don't actually need to animate from bottom to top. We only need to animate as long as it takes for our reference line to move from the bottom to one line up, and then we can reset. So we only need to animate, you know, like 10% or whatever. 10% up, then reset, 10% up, then reset. And by looping that little animation over and over and over again, it will look like continuous motion forever. So let's figure out how to do that. Well, we know that we have this distance delta. So we're changing our percentage by 10% per line. What if we take the distance percent? This is our baseline. This is our reference line, the one at the bottom here. What if we just mod that by 10%? Mod by 10%. Because we know the next line is going to be 10% further. So once, like if this distance percent, whether it's 0.2 or 0.12 or 0.22, those are all the same situation as far as we're concerned. And so the moment that we get above our distance delta, which actually I should pass the variable in there, not the number. The moment that we get to distance delta, we'll just reset. Let's save that. Okay, I think what we're going to try to do here is, even though we have this glitch at the bottom, let's solve the spacing problem, and let's see if the spacing problem happens to also solve that bottom glitch. Now again, the spacing problem is that we want lines at the bottom to be spread out more than the lines at the top. Less dense at the bottom, more dense at the top. What we'd like to be able to do is pass in the percent and get a y value that's calculated appropriate. We'd like to say horizontal line at time. Now the distance percent can also be thought of as time. Rather than saying like horizontal line and then we'll say y, instead of saying like y at distance, well, we could say y at distance, I guess. Y at distance, and we'll call this distance percent. But now the question is, what do we do with that number. So we're getting a number between 0% and 100%, and somehow we want the line to move less near 100% and more near 0%. First, let's restore what we're already doing to make, let's not break our existing calculation. So we're going to return, and I guess we need our size in here. We're going to return size.height times 1 minus the distance percent. That's the calculation we've already got. Let's make sure that's still working. So here we'll say horizontal at y. Okay, and then let's copy that. We calculate it in 2 places. There as well. Let's save. Okay, I've saved, nothing's changed, that's good. So down here, this is how we turn a distance percent into a y value. And now what do? This is where we want to start thinking about some common mathematical functions. What is a function that has essentially a greater slope at 0 and a smaller slope at 1? Or, yeah, I mean, that's what we want. So there are a few thoughts that come to mind. One thought is square root. Square root could work. It might have some issues at the extremities that we'd have to play with. And I think perhaps an easier function to go with is a sine function. Think about the first 25% of a sine wave, the part that's in the first quadrant. Sine at 0 is 0. Sine at 90 degrees is 1. And the sine changes faster near 0 and slower near 1. So maybe we can use a sine wave to space these lines out better. So let's say adjusted distance percent. And that's what we're going to pass in down here is the adjusted distance percent. We're going to set that equal to the sine of, first we're going to say pi divided by, so pi divided by 2 is 90 degrees. That's the first quadrant. And then we're going to multiply that by our incoming percentage. What this means is what percent of the first quadrant, what percent of this first quarter of the pie do you want? And that's it. That's going to be our adjusted percent. Oops, this should be distance percent. We're converting a percent to a percent because remember, sine wave, sine is also between 0 and 1, at least in the first quadrant. So we're going from a percentage to a percentage, but we're changing how spaced apart the values are. Let's save that. All right, woohoo, we did it. I had to go debug some stuff. The part that matters is right here. What I got us into some infinite loops because we were never quite getting to 0 in our calculation. So our loop was never, the loop that calculates the y value was never ending. You could adjust that in a few different ways. I just took a real simple hack right here where I take the incoming percent and I make it 5% larger than it should be, which should always push us beyond that 0 point. This calculation eventually should give us a number that sits up above the top of our available space, which then triggers the loop condition, and then we break out and things continue. So I had to go figure that out. But notice 2 things. First, our glitch at the bottom appears to be resolved simply by adjusting things for perspective, so crisis averted. And also notice that now it actually feels like we're looking at a perspective because the lines at the top are closer together than the lines at the bottom. We've now imitated a perspective effect. Now, is it exactly the same perspective that you see in the app? I'm not quite sure, and we're definitely moving a bit faster, but those are both things that you can easily change in your own code if you want to. There's one last cherry on top, though, that really adds a nice effect and something that you would want if you're going to use this the same way that Robinhood has used it, which is we need to fade out at the top. So let's come up to our widget, come up to our custom paint. See, where are we here? Custom paint. We are going to use an approach that we used way back almost a couple years ago when I was cloning a capability in the Nest app. We are going to use a shader, another linear gradient, to apply a shader mask. We're going to wrap this with a shader mask. And then we need to supply a shader callback. And the reason this is a callback is because shaders always operate on pixels. They need the actual size. They need to know how many pixels we're shading. And then we need to return a shader that will shade that size, those pixels. And actually, I got that wrong. It's not a size, it's a rect. So it actually has possibly a position as well. But what we're going to return is a linear gradient. Now, this is like the third variation of linear gradient, right? We already used one earlier, which was ui.gradient.linear. Now we're using this thing called linear gradient. And at the end of this, we're going to create a shader with the given rect. Let's save that, and now we need to fill these things in. Let's start with where we begin and end. And notice that this one now takes an alignment. I told the other one we used took pixels. This one takes an alignment. We're going from top to bottom. And now here's the thing about the colors. What colors do we want for this shader? We are masking another widget. Masks, it depends what kind of mask you're dealing with, but in this case, this mask is going to treat white. It's going to show everything beneath the white pixels, and it's going to hide everything beneath the black pixels. Now, we don't want to just be black and white. The reason we're using a linear gradient is because we want to fade. So we want to fade. Actually, I take that back. It's not white and black in this one. It's transparent and non-transparent. So we want to fade from transparent to opaque. And we'll settle with the color white because why not? But what we want to do here is colors.white with opacity. We're starting with no opaqueness at all, totally transparent. And then we'll say colors.white with opacity 0.7. And that's because we're actually going to fade everything a little bit. Even the parts that are fully painted, we're just going to paint 70% so that we have the whole thing is a little bit translucent. And then, in theory, you could stop right here because we go from totally transparent masking to essentially as opaque as we want to be. However, we want greater control. Like we don't want to fade all the way to the bottom. We don't want to fade from top to bottom. We just want to fade near the top. So I'm going to add another color that's exactly the same as the one above it so that we can have a region that is fully opaque essentially. And I'll show you what I mean down here. This impacts what are called the stops. The stops are the places where each of those colors are applied. We're going to be totally transparent from 0 to 0.1. And then we're going to fade. By the time we get to 40% of the height, we're going to be totally faded in, and we're going to carry that down to 1.0. Let's apply that mask. All right, check it out. See, now we almost have like a fog in the distance, right? And that's similar to what we see down here in the actual Robinhood app. As you fade off into the distance, literally it fades out. And that's accomplished here. Now maybe we can actually remove this final stop. Let's see what happens. Maybe maybe it's implied. Yeah, I guess it's implied. So, okay. What I said before about stops, it's true, but there's an implied stop at 0 and an implied stop at 1.0, and it just copies these colors. So that's handled for us. Now, I think the last detail that I want here is to actually use a brighter green that looks more like the Robinhood app. So let's go back to our demo and let's replace this kind of evergreen looking color with a different color. Let's save that. All right, now we're looking much more like Robinhood, right? Looks a lot, it's not exact, but it looks a lot more like what we've got down here below. And again, in terms of speed, you can adjust that. If we find, where's our ticker here? Let's say we want it to take, let's double it up. Let's say 6 seconds. Now we're much slower. The Robinhood one might be as much as like 10 or something. It's looking pretty slow. Even slower than that. Well, the point is you can play with it at this point using a custom painter and kind of estimating where lines should go. We have been able to simulate a perspective effect that looks like the animated neon horizon in Robinhood's crypto experience. So we'll see you in the next battle of the Clone Wars.